This tutorial is a set of videos outlining a number of steps to build a full Spring Boot application featuring a Kotlin service backend, a Java client, and a JavaFX user interface. The first step in the tutorial is to create a Kotlin Spring Boot application which serves as the backend of the application. In this video, we'll create a REST service that can be connected to in later parts of the tutorial. Let's create a new project for our Spring Boot service. Since we're using Spring Boot, we'll select the Spring Initializer option on the left of the New Project window. We can select which SDK to use. We'll use Java 13 for this project. We enter a group name for our project and an artifact name. We can build this project with Maven or Gradle, and there are various options here. We're going to create a Maven project, which will generate the pom.xml and Maven wrapper files that we need. For this service, we're going to choose Kotlin as our language. We'll select Java 11 here, as this is the most recent long-term support version for Java, but for the purposes of this project it makes no difference. The name is automatically populated from the artifact name, we don't need to change this. We should add a useful description for the project, and we can optionally change the top-level package too. We can choose which version of Spring Boot to use, including the most recent production-ready version or snapshot versions to try out. We're going to use 2.2.0 RC1 for this tutorial because later we'll be using features that are only available in the release candidate. We can also search for and select which Spring Boot starters we want to use. This will be a reactive REST service, so we want reactive web. We'll use the defaults for project name and location. IntelliJ IDEA will use Spring Initializer to create the project and then import it correctly into the IDE. Let's enable auto import on Maven, so if we make any changes to the pom.xml file, the project will automatically be refreshed and rebuilt. You can see that IntelliJ IDEA automatically recognizes this as a Maven project and opens the Maven window. In the project window, we see the structure of the project that has been created, including a Kotlin directory and the standard default application class that Spring Boot creates. IntelliJ IDEA Ultimate has full support for Spring applications, which includes gutter icons, making it easier to identify and navigate between Spring elements like Spring Beans. If we take a quick look at the generated pom.xml file, we see not only the selected Spring Boot starters and Kotlin dependencies, we can also see the Spring compiler plugin in the Kotlin Maven plugin. This makes it a bit simpler to work with Spring in Kotlin. Let's go back to the application class and run it using the shortcut Ctrl-Shift-F10 for Windows or Linux, or Ctrl-Shift-R for Mac, just to see that everything works together correctly. We can see it started successfully with Netty running on port 8080. Let's stop it with Ctrl-F2 or Command-F2 for the Mac. Now we know it all works, we can get started on our own functionality. Let's create a class for our REST controller. We'll put it in the same Kotlin file to keep things simple for now. We need to annotate this as a REST controller. We can use the fun1 live template to automatically create a Kotlin function that takes a single parameter. We'll call this method prices, and it takes the symbol of the stock we want to get the prices for. This method will return a flux, which will be a constant stream of prices. This is where the reactive part comes in. The flux will emit stock prices. I use Alt and Enter to get IntelliJ IDEA to automatically fix up my code. And then we need to create this new stock price class, which will represent all the data we need to know about the price of a stock. Again, we'll keep this inside the same file to make it easier to see. We're going to create this as a Kotlin data class. This is a compact way to declare a class with properties. In Java, this would have getters and maybe setters, and equals, hashcode, and toString methods. But in Kotlin, we simply declare what we want in the constructor parameters. We want a symbol for the stock, which is a string, a price, which is a double, and the time associated with that price. Here we're using Java 8's java.time.localDateTime. Now we're going to define what the prices method returns. This method is going to create a flux which emits one randomly generated price every second. We can do this with an interval with a duration of 1 second. Then we can use map to create a new stock price for each of these seconds. Note that in Kotlin we don't need the new keyword. The stock price needs the symbol, a price, which for the purposes of this tutorial will be randomly generated, and a time, which will be now. Let's import this now method to make the code a bit shorter. Now we'll create the random stock price function. IntelliJ IDEA knows this needs to return a double because of the stock price constructor. One way to create an arbitrary double is using thread_local_random and the next double method. Let's generate a number between 0 and 100. The last thing we need to do to make sure this compiles is to return this flux. Since we want to be able to access this method via an HTTP GET call, we need to add the GET mapping annotation to it. We'll give it a path. I tend to define this as a string parameter and then get IntelliJ IDEA to turn it into an array. We need to define what the response to this method looks like. We're going to use text event stream value. So this is a server sent events streaming endpoint. Again, I'll use IntelliJ IDEA to wrap this in an array. One final warning from IntelliJ IDEA that needs fixing up. The IDE has detected that we're using a path variable, but we haven't defined it in the method parameters. One way to fix this is to get IntelliJ IDEA to create the path variable and remove the parameter we created earlier. If we run the application, we can see it starts up correctly. If we open up a web browser and navigate to the path we defined, we'll see the events tick once a second and see the stock price represented as a JSON string. We've created a simple Kotlin Spring Boot application that uses reactive streams to emit a randomly generated stock price once a second. In the rest of this tutorial, we'll show how to connect to this server to retrieve prices and how to create a chart that shows the price updates in real time. Thanks for watching.